today we are going to be taking a look at combinations and permutations in terms of probability and how they apply to this thing called Pascal's triangle. All right, so first, just a little heads up. Pascal, he's a famous mathematician, all right? I'm just going to write math guy, mainly because I ran out of space to write the word mathematician. But he's famous, okay? You could look him up, Google search him sometime, all right? He's cool. Lots of really neat math things. But the biggest math thing that he tends to be known for is this triangle we're looking at today. So the first thing I want you to do is take a moment and pause the video after I ask you this question. And the question is, can you find the pattern in this triangle? There is absolutely a pattern. Well, there's kind of a lot of patterns if we're being like transparent. So can you find the pattern in this triangle? And if so, fill in the rest of the triangle with that pattern. So pause, take a look, see if you can find it. And then when you unpause, I'll reveal the pattern. Did you pause it? I really hope you did. All right, I hope you thought about it for a moment. Okay, so here's the pattern. If you start at the top, so here's the key thing. You're going to start at the top. By the way, this spot right here, this top part, would be considered row 0. All right? If you start to look, there's sort of just this pattern of ones kind of going all the way down the edge. That's the first pattern I might notice. All right, but then as you move forward, so like this is row 1, row 2, if you look at these like interior little spaces, they're the sum of the two pieces that are kind of touching it, right? So 1 plus 2 gets you 3. So if I was going to fill in this missing spot, it'd be a 4, right? Because 1 plus 3 is 4. So then we'd have 5 and 10, right? And then we'd have 6 and 15 and 20 and 15 and 6. Now, another pattern that I'm hoping you're starting to notice is that there's a little bit of symmetry going on, right? If I kind of cut this little triangle in half, if you look on the left or right side, if there's an even number of numbers, there's a pattern. Like look here in row 5. It goes 1, 5, 10, then 10, 5, 1. All right, so I'm going to fill in the rest of this, okay? You guys, just follow along. You might need your calculator eventually because these values are going to get a little bit, large. It's right about here where things start to get, well, not maybe this particular row, but it's kind of like after row 8. You've got to, you're okay, and then all of a sudden you're in the 100s, right? Okay, so we're on row 9 at this point. And remember, once you get the first half of the row, you just need to kind of copy, like mirror that down, okay? Because of that symmetry I was talking about. Okay, so 10. At this point, you should just be kind of cruising through, writing all these numbers down. Remember, I'm just adding, the top 2, right, that kind of feed into, they kind of touch that next little cell, okay? And my design here is these little hexagons, but really they could be circles. Like they come in lots of different representations. So, nothing too crazy, but what you might be wondering is why are we writing all these numbers down? Like, what does this triangle thing have to do with probability? Well, if you are wondering that, I'm so glad you asked. let me answer that for you. Okay, so one thing that I hope would make sense is that like the triangle continues infinitely, okay? I've just shown you 11, well, really 12. No, 11. 11 rows, right? Because first row is row 0. I've just shown you 11 rows of this triangle, but it would go on forever. Okay, so how does this relate? Well, Pascal's triangle, it is used for probability calculations related to equal outcome scenarios. And I guess to be more specific, it should be equal to outcome scenarios. Okay? So, you know, heads versus tails, equal outcome. Boy versus girl, is somebody having a boy or a girl? That sort of a thing. Okay? Unless there's like significant reason to believe this, a win versus a loss, right? Equal opportunity in those situations. And so to give you a scenario, I'm going to give you this example right here about probability in Pascal's triangle. So you could use it to find, let's say, the probability of any boy-girl combination in a 5-child family. So here's the deal. The row that you're in, so this is just a general rule, the row total is always equal to the sample space. Okay, so since I said a 5-child family, we're going to say R is 5. Okay, so that means the row we're going to be looking at is this row right here. Okay, this is row 5. All right, and if I add up all the cells, I've got a 1, a 5, a 10, another 10, 5, and 1. There's a grand total of 32, okay? That's what I've got written down here, so my math checks out. There are 32. That means the sample space. How many different ways could a family have 5 kids? There are 32 combinations of boys and girls that they could have. Not like 32 kids. I mean, there's 32 ways you could figure out how many boys or girls they have. So the number at the end, here's what's really interesting about the triangle. The numbers at the ends are the least likely combination, because here's what you want to think about it. Here's why there's like a 2-person situation. In fact, I'm going to write this down here. You know how it's like 1, then 5, then 10, then 10, then 5, then 1. That's the row. The first thing is having, let's say, 5 boys and 0 girls. Okay? So it's 5 of 1. Then it'd be 4 boys, and then 3 boys, and then 2 boys, and then 1 boy, and then having no boys. That's why even though it's row 5, there are 6 options, because technically there's a situation where you could have none of whatever one of those outcomes are that you want. And so then by extension, it would increase 1 girl, 2 girls, 3 girls, 4 girls, 5 girls, right? And no boys. Okay, so the things on the ends are the ones that are least likely to occur, right? When you have all the same outcome happening every single time. So that's what this is, 1 out of 32. And then the middle numbers, they tend to be the most likely outcomes, because there are lots of ways you could have had 3 boys and 2 girls, or 2 girls and 3 boys. And those tend to be equal. And in this situation, because 3 and 2 and 2 and 3, like 2 boys, 3 girls, they're sort of similar. That's why they end up being the same number, even though they're 2 different situations. Okay, so we're going to use this triangle. Now, I took a screenshot of a slightly different one just to help our visual when we're looking at a specific row as we're doing a problem. So the first question says, what's the probability of tossing a coin 8 times and getting all heads? Now remember, 8, that's like 8 trials of this situation. We're going to look in row 8 to help us answer this question. So if I look at row 8, I want to know what's the probability of getting all heads. Well, that would be the first number or the last number, which either way is both 1. And then if I add up all of these numbers, I'm actually going to get 2 to the 8th. We'll talk more about why that happens later. But that should be 256. So the probability of that happening is 1 out of 256 trials that you actually get all 8, or like 1 out of 256 attempts. Okay, next one. Tossing a coin 5 times. So we're back in row 5, right? Which the sample space was 32 for that, okay? So, and getting probability of getting 3 heads, 2 tails, okay? And remember, this is going to be the same as 2 heads and 3 tails. It's going to be that number in the middle. So that answer is going to be something out of 32. So imagine I had all heads. Let's see, what are we tossing 5 times? 5 heads would be here, 4. So 3 heads must be this, 10. So 10 out of 32, which we are going to simplify. All right. We're going to make that 5 out of 16. Probability of having a family of 9 girls. All right, if we look at row 9, that's going to be this first number, right? 1, and then our sum, if you add up all these numbers, that is 2 to the 9th, all right, which is 512. 1 out of 512, okay? Now, by the way, if you're wondering, well, how do I know that it's likely going to be 2 to the 9th? Well, because this is a 50-50 probability, 1/2 to the 9th power would be the same thing as 1 to the 9th over 2 to the 9th. So that's why it's 1 over, that's why it's this answer. I do want to point out that this triangle is mostly for the stuff that's in the middle, right? You know when there's only one chance that something could happen. It's when there's like, kind of wishy-washy, like I don't know how many times that thing could happen because it could happen a lot of different ways. That's why we have the triangle. Okay, like this situation. The probability of having a family of 3 girls and 1 boy. So our size is 4 for our whole family. So that means we want to look in row 4. Okay? So probability of 3 girls, 1 boy. All right? So row 4. Let's go to row 4. This guy right here. So it looks like my sum is 1 plus 4 plus 6 plus 4 plus 1. So that's going to be 2 plus 10, so 12, so 16 total. And I want to have 3 girls, not 4 girls, 3 girls. So if 4 girls was here, 3 girls would be this guy right here. So it'd be 4 out of 16. So that equals a 4th. All right, so those are a few, ways we can use the triangle, right? Pretty much anytime there's a 50-50 shot of the outcomes, only 2 outcomes, you can use the triangle. So that's what we want to write down here just as a little note to ourselves. Under what conditions can you use the triangle? When precisely, so no more, precisely 2 outcomes of equal, aka 50-50, probability are present. So if you knew that one outcome had even the slightest likelihood more than the other to happen, you couldn't use this triangle, okay? Now, in terms of our combination notation, so I want to remind you, NCR, that's like your total combination. I'm just putting this in parentheses. Total combinations of, and then your group size, right? Remember, those are your, numbers. That's what N's your total. R is how big of a group, right? So if I wanted you to have, let's say, 8CR, 8 is your total that you have available, and R, I'm sorry, I don't know why I wrote an R. this number would be like your group size, or how many you're going to pick. Pick this many. You got a box of 8 chocolates, you're going to eat 3 of them, right? You've got 8 people running for representatives of the senior class. You're going to pick 3 of them. That's that number. So how does that translate in the triangle? In the triangle, this would be your row number, and this would be your position in the row, okay? Now, we're going to do one other thing. We are going to take a moment, and we are going to do a little coloring. Okay, so shade in all the multiples of 5. So let's go back to our original triangle. Let's shade in anything that is a multiple of 5. And I get that that is not a good highlighter color. I'm going to see if blue's better. Blue's a little bit better. Okay, multiples of 5. 15, 20. All right, here's some multiples of 5. Next time I see a multiple of 5 is over here. Okay, things that end in 5, things that end in 0, right? Things that end in 5, things that end in 0. All right. Do you notice anything about this shape? Or you want to take a guess at what this shape down here is going to be? It's another triangle. More triangles, right? If you look, you can't see it because we didn't do all of them, but here's the rest of that triangle. Ooh. Ooh, I went a little bit off, sorry. See? Here's that triangle right there. 10 to 7, yep, right there. Just repeated triangles showing up all over the place, okay? So there are more patterns. A triangle in the triangle. Whoa! Find the sum of the numbers of each row. What pattern do you notice? All right, let's see. I'm going to do it on this one because there's just a little bit less written here. All right, this is 1. The sum of the second row is 2. Third row, 4. Fourth row is 8. This one we said is 16. This row is 32. This row, 64. Now, I will tell you, I know the pattern, so I'm doing my math a little bit faster. I should have told you to pause and add these up for yourself. I am so sorry. But at any rate, please forgive me. But I wonder if you know the pattern. Here's the question. Do you know this set of numbers? 1, 2, 4, 8, 16, 32, 64. That's the question. Do you know what pattern this is? Well, they're all even. I hope you saw that. But more importantly, they're all powers of 2. Right? 2 to the power of. That's what they all are. Okay? That's what Pascal's triangle is partially built on. That power of 2. It relates back to the fact that things that have a 50-50 probability have a 1/2 chance each of happening. So every time we get a new row, we take that probability of the edges to the n, right? 1 out of 4, 1 out of 8, 1 out of 16, etc., etc. All right, if you don't mind, maybe look up something about Pascal's triangle on the internet. Do a little Google search. Share that with the class. Share that with me. I'm always looking for new fun things to learn about mathematics. All right, now most importantly, do a little bit of practice. Never hurts. Practice makes perfect. And we'll see you back here soon. All right, have a great rest of your day. Thank you for listening, and I'll see you later. Bye, you guys.